Hi, my name is Saket Kenjale, and in today's video, we're going to be covering topic 1.2, basic classes of functions. So we're going to jump straight into linear functions and slope. So I hope you guys have all seen the y is equal to mx plus b function. And in today's video, we're going to be writing it as f of x is equal to ax plus b. And so some things to note here is that if a is rising as x increases, so as x is getting bigger, then that means a is going to be greater than 0, which means that it's increasing on the interval negative infinity to infinity. And if a is falling as x increases, then that means a is less than 0. And that means it's decreasing on the interval of negative infinity to infinity. If a is equal to 0, then this line is going to be horizontal. It's going to look something like this. It's just going to be a line like that. So now, what is the slope of a function? The slope is the change in y for each unit change in x, and it measures the steepness and the direction of the line. And so, for point x1, y1, and point x2, y2, the slope of the line is depicted right over here. So y2 minus y1 over x2 minus x1. And so there is also another way of writing it, and this is said as delta y over delta x. So this triangle over here means delta, and it means the change in. Okay, and so this is equal to our a value over here. So right over here. And also you could call it m, so I'll write that. So this can also be equal to m. And so now there's a couple ways of writing the equation of a line. And so the first one that we're going to go over is point slope form. And so it's right over here. It's y2 minus y1 is equal to m times x2 minus x1. And then we have standard form, which is ax plus by is equal to c. And lastly, we have slope-intercept form, and let me write that down here. So we have slope-intercept form, and that is the y is equal to mx plus b, or the f of x is equal to ax plus b. So that's slope-intercept form. And now we're going to go over an example problem. So it says, consider the line passing through the points 11, negative 4 and negative 4, 5. So they want us to find three things. They want us to find the slope. They want us to find the point slope form of this equation of the function, and they want us to find the slope-intercept form of this function. So I want you to pause the video, see if you could try solving these three things, and then unpause the video when you're done to see the solution. Okay, so this is what the equation, this is what the function looks like. And so to find the slope, a, that is equal to y2 minus y1 over x2 minus x1. So we'll call this point, point 1, and we'll call this point 2. So that means that this is y2, this is y1, and this is x2, and this is x1. So if we were to find the slope, it would be negative 4 minus 5 over 11 minus negative 4. And this is equal to negative 9 over 15. So this is our slope. And I hope this also makes sense because it's negative. So that means that the function is decreasing as x is increasing. And that's what's being depicted here. So now let's find the point slope form. So we have the 2 points and we have the slope, so we just need to plug in all the values. Point slope form is y2 minus y1 is equal to m times x2 minus x1. And so, sorry, I did this wrong from the beginning. This is not y2 minus y1. It's just any point. So it would be y minus y1 is equal to m times x minus x1. So this stays as y and this stays as x. So plugging in any point into this, we would get y minus negative 4, so it'll be y plus 4. I'm plugging in point 2 is equal to negative 9 over 15 times x minus 11. So this is our point slope form. And I'm going to put it right over here. So this is our point slope form. Our slope we got to be negative 9 over 15. And now we just have to find slope-intercept form. So an easy way to solve for slope-intercept form after you've solved for point slope form is to just distribute this into that and then subtract by 4. So let's do that right now. So we have y plus 4 is equal to negative 9 over 15 plus 99 over 15. And then I'm going to simplify this. I could have simplified this earlier, but I didn't for some reason. But this becomes 3, and this becomes 5. And this is 3/5 x, by the way. So let me rewrite this as y plus 4 is equal to negative 3/5 x. And we could simplify this. This would become 33, and this would become 5. So it'd be plus 33 over 5. And so now we just subtract 4 from both sides. And we could write 4 as 20 over 5. So this is the same thing as subtracting 20 over 5 from both sides. And so our slope-intercept form is equal to y is equal to negative 3/5 x plus 13 over 5. So these are the 3 solutions to this question. And we could also write all of these functions in terms of f of x and x instead of y and x. So for point slope form, we could write it as f of x plus 4 is equal to negative 3/5 times x minus 11. So this is the same thing as this. And then for slope-intercept form, we could also write f of x is equal to negative 3 over 5x plus 13 over 5. So these two are the same thing. Now let's look at an example problem 1.13, which is a word problem. So it says Jessica leaves her house at 5:50 a.m. and goes for a 9-mile run. She returns to her house at 7:08 a.m. Answer the following questions, assuming Jessica runs at a constant pace. So before even looking at the questions, we have three pieces of evidence. So she starts her run at 5:50 a.m., ends it at 7:08 a.m., and it was a 9-mile run. So question A is just asking to describe the distance d in miles that Jessica runs as a linear function of her runtime t, which is in minutes. So let's do that. So we're going to end up getting the function d over t. And so what we have to do is we have to find the slope, which is a in this case, and the y-intercept, which is b. So let's do that. So based off the information in the question, we can calculate how long she ran, how long it took for her to run 9 miles. And so by calculating it, you would see that she took 78 minutes to run 9 miles. So already we could see that we could create a point. In 78 minutes, she ran 9 miles. And if you think about it like this, when she started her run, she ran for 0 minutes, and in that time she ran 0 miles. So now we have 2 points. We have point 1 and we have point 2. And with this, we can calculate for a, the slope. So putting that in, it will become 0 minus 9 over 0 minus 78. That is equal to 9 over 78. And simplifying that out, if you divide by 3 on both top and bottom, you'd see that we would get 3 over 26. So, plugging this into our d of t function, we would get 3 over 26 x plus b. But b in this case is 0 because our y-intercept is at the point 0, 0. So b would be 0, and then our final function would look like this. D of t is equal to 3 over 26x. And now let's look at b. So it's asking us to sketch a graph of d. So this was a. Now let's look at b. So there is no negative values, so I'm only going to draw the first quadrant. I can do better than that. Let's draw a straight line. Okay. So we know that there's a point 0, 0. There's also a point 78, 9. So it goes all the way to 78. Let's call that 78. Let's call this 9. So based on that, we can say the point is over here. Now we could draw a straight line that connects it like that. And that goes on like that. So this is our graph. Now interpret the meaning of the slope. So this slope, which is, we got to be 3 over 26, is Well, the slope describes the distance in miles that Jessica runs per minute, and in in that sense, it is known as the velocity because it is 3 over 26 uh, miles per second, which is a unit of velocity. Sorry, it was miles per minute. So, and so now we're going to talk about polynomials. So, a polynomial function is a function that could be written in the form of f of x is equal to an times x to the power of n plus an minus 1 times x to the power of n minus 1, and it goes so on and so forth till we get to a1 times x and plus a0. So some things to know and some key concepts to grasp from this interpretation over here is that n is the degree of the polynomial, and the degree is the greatest exponent that is there. So in this case, it could be like 5, 10, whatever. It's just the greatest exponent value in this function f of x. And n has to be greater than or equal to 0 for this to be a polynomial function. An is the leading coefficient, and so this is the leading coefficient. And an cannot be equal to 0 because then it'd be 0 times your x value, and then that would just be 0 altogether, and then your n wouldn't exist. So yeah, you get it. And so there are two specific polynomials that I would like to talk about, which are quadratic and there is cubic. And so quadratics are polynomials that have a degree n of 2. So n is equal to 2, and the quadratic base function would look like f of x is equal to ax squared plus bx plus c. So this is the quadratic function, and then the cubic function has x cubed, and then it goes all the way down 2 plus c, just like that. Now we're going to take a look at power functions. So power functions are in the form f of x is equal to ax to the power of n, where a and n are real numbers. And in today's video, we're not going to be considering power functions where n is a negative number, because then we will get the function f of x is equal to a over x to the power of n, and this is not a polynomial function. But we are looking at polynomial functions today, which is why we're only looking at cases where n is greater than 0. So like I said, if n is greater than 0, then the power function will be a polynomial. If n is an even number, like 2, 4, 6, 8, 10, 12, and so on and so forth, then this is an even function where it's symmetric over the y-axis. If n is an odd number, then it's an odd function, and it's symmetric over the origin. We went over this concept in the last video, 1.1 Review Functions Part 3, so if you need a review on that, then go check that video out. So there are no practice problems for power functions, so this is going to be it for topic 1.2 Basic Classes of Functions, and we are going to be continuing this in our next video, and that's going to be part 2.